Welcome to this video supplement involving solving equations using a U-substitution to form equations that appear to be a quadratic equation. We are going to look at three examples in this video tutorial, the first of which is pictured on the screen. Now, when solving quadratic equations, we prefer to get a zero on one side of the equation and everything else on the other side of the equation. So that will be our first step. Now we stop and look at the equation and think, how can we make it look like something squared? In this case, we have an x to the fourth. We have an x squared. So what we can think is, let's do a u substitution where u is equal to x squared. Because if we consider that substitution, the original equation becomes x squared minus x squared minus 20 equals 0. And then when we make our substitution, we get u squared minus u minus 20 equals 0. We can factor this equation to solve. Two numbers that multiply to be negative 20 and add to be negative 1 would be a negative 5 and a positive 4. So at this stage of the game, we would know that u minus 5 equals 0, which means u equals 5, and u plus 4 equals 0, which means u would be equal to a negative 4. However, we're not done. We need to have the final answer in terms of x, as the problem was presented in terms of x. So now we go back and we change from the u into an x squared. So on the left-hand side here, we would be saying x squared equals 5. On the right-hand side, we would be saying x squared is equal to a negative 4. We take the square roots on both sides. Remember, when you take the square root, to put the plus and minus option in there. Take the square root, put the positive and negative option in there. So on the left-hand side, we get that x is equal to plus or minus the square root of 5. And on the right-hand side, x is equal to positive or negative the square root of 4 times the square root of negative 1, which means x is equal to plus or minus 2i. Now, a couple notes here worth mentioning and certainly worth considering. Let's look at the original equation. So our original equation, x to the fourth equals x squared plus 20. We would want to check our answers and ensure that they work. In this case, we're just going to highlight these answers here. But make sure you check to see if they work. Plug them back in. In this equation, they'll be okay. In some other equations, they might not be okay. Also worth noting is when you read the problem, if it says only real solutions, please don't include the complex ones, x equals plus or minus 2i. However, if it says find all complex solutions or find all solutions, then you would include the x equals plus or minus 2i. Let's shift our attention to our second problem now. And this problem also thinks about a quadratic application using a u substitution because we see a quantity being squared. So the first thing we're going to do is get all terms on one side of the equation and 0 on the other side of the equation. And in this problem, we're going to do a u substitution where u is equal to x over x plus 3. Once we make that substitution, the equation becomes u squared minus 3u minus 28 is equal to 0. I believe this is another one that can factor. We can find two numbers that multiply to be a negative 28 and that add to be a negative 3. In this case, that would be a negative 7 and a positive 4. So we would have u minus 7 is equal to 0, which gives u equals 7. Or u plus 4 is equal to 0, which gives that u is equal to a negative 4. Then we have to go back and actually solve for x. So we would say x over x plus 3 is equal to 7. and x over x plus 3 is equal to negative 4. We would multiply through by x plus 3 on both sides of our equations in order to cancel out the fraction. On this first equation, we would have x is equal to a 7x plus 21 when we distribute the 7 through, which means that a negative 6x is equal to 21. X is a negative 21 sixths, and if we simplify, top and bottom are divisible by 3. That would be a negative 7 halves for x. On the equation on the right-hand side, we would multiply both sides by x plus 3 in order to cancel out that fraction. We would have x is equal to a negative 4x minus 12. So 5x is negative 12, which gives that x is a negative 12 fifths. Of course, we would want to go back and check those solutions in the original equation. In a problem like this, the main thing to be mindful of is that we wouldn't want an answer or a value of x that makes the denominator 0. So if we had a solution pop up that said x equals negative 3, that wouldn't be correct. It would be extraneous because we can't have a solution where we would be dividing by 0. We have one more problem that we are going to consider in this video supplement, and that problem is currently pictured on the screen. Again, the first thing we want to do is build 0 on one side of the equation and get everything else on the other side of the equation. Now, as we look at this problem, if we thought about the substitution that u is equal to the square root of x, how this equation really would look is 3 times the square root of x being squared minus 7 times the square root of x minus 6 is equal to 0. When we make the U-substitution, then, we get 3u squared minus 7u minus 6 is equal to 0. This is another one that I believe we can factor. We would have to start off with a 3u and a u. And then if we put a minus 3 here, we would have a negative 9u. A plus 2 here would give us a plus 2. Negative 9 plus 2 would become our negative 7u. So as we solve this, 3u plus 2 equals 0. 3u is equal to a negative 2, which means u is equal to a negative 2/3. On the other hand, u minus 3 equals 0. So u is equal to 3. Don't forget we need to solve for x though. So we plug back in. Square root of x is equal to a negative 2/3, or the square root of x is equal to 3. Is the positive square root of x ever going to equal a negative 2/3? And the answer on that one is no. We will not get any solutions from having square root of x is equal to a negative 2/3. But on the right hand side here, if we square both sides of this equation, solving for x, we would get that x is equal to 9. Of course, it's nice to go back to the original problem and check our answer. If x equals 9, 3 times 9 is 27, minus 21. 27 minus 21 would be 6, and 6 minus 6 would be equal to 0. So really, the U-substitution is a very helpful strategy to convert some other type of equation into a quadratic equation that we can then either factor or use the quadratic formula or even complete the square to solve.